Hi everyone, we will continue on with the statistics chapter. Today in this video we're going to look at some charts. We're going to look at the histogram, stem and leaf, the line plot, and then how to do a scatter diagram. So let's start with the histogram first. It's often used to display information contained in a frequency distribution. So a table that gives you frequency distribution data. An easy way to represent that data is on a histogram. Now, you be careful, as part of your course you could get asked to display data in a suitable chart. So this is the reason why I'm explaining to you what type of data is suited to a particular chart, and in many cases there isn't just one chart that is suitable, but there are certainly some charts that are not suitable. So histogram, anytime you see intervals like such, that is perfect for a histogram type chart. It's also good for like a pie chart would work very well as also. A bar graph would work well. The difference between a bar graph and a histogram is that a bar chart has spaces in between the bars. Okay, so a histogram is similar to a bar chart, except a histogram has no gaps between the bars, and the two are often confused. It is worth remembering that bar charts can only represent discrete data, while histograms can represent discrete or continuous data. So if you remember back to the different types of data, continuous data can be any value. So again, let's come down to this example here. This data is continuous in that there's no gaps in the data. So any value between 0 and 20 falls in here. Any value between 20 and 40 falls in here, 40 to 60. So every possible value, decimal or not, is covered by these intervals. A note on one of these charts, you should always have a note to tell you, for example, where does 20 fall? Does it fall into this category or does it fall into this category? Because the way it's written at the moment means it could fall into either. So if you design your frequency distribution table like this, and it's perfectly fine, you just need to have a note to accompany it. So 0 to 20 means 0 is included but 20 is not. So basically this is 0 to 19. This is 20 to 39, this is 40 to 59, and so on and so forth. The reason they write it like this is because they want it to be fully continuous. So in other words, I'm saying 0 to 19, really it's 0 to 19.9999999 falls in here. Okay, discrete data then on the other hand has just set values. So in other words, this could be marks obtained in an exam. So if you could only get your marks in set figures, so these 8 students got 10 marks, for example. These 21 students got 30 marks. So pretend you could only get 10, 30, 50, 70 or 90 in this particular test. Okay, that's discrete data where it goes up in set values. So a histogram can represent discrete or continuous data. A bar chart cannot do continuous data because it's got gaps in the middle. So one of the most important things about a histogram is that the area of each rectangle represents the frequency, and the sum of the areas of the rectangles is equal to the sum of the frequency. So in English, what does that mean? Okay, it means that the widths of your bars, if I could call them that, is very important. So the widths, if they go up in the same amount, so in this case you see they're going up in 20s, that means that you should have the width of each of these columns the exact same. Okay, that is very important because a histogram is a picture and you have to get a feel, for example, how many people are between 20 and 40 from this picture. So if you have different widths for your columns, then your mind processes that different. Okay, the other thing that's really important is that you see the intervals that's here in these questions, they don't have to be the same amount. So they didn't have to go up in 20s. So for example, I could have had maybe here 0 to 40. So I could have combined them and got a total score of 29. Okay, what would happen in that case though is that this width here, 0 to 40, has to also be double. If it's going to be double the interval width in the table, it has to have double the area. Okay, and that's how we figure out how many people are in each category, or as a picture, what interval widths are we talking about. Okay, I'll go down through your exam questions in due course, and I'll see is there any exam question that's got different widths, or are they all the same widths. And if there is one with different widths, I will do that as part of a video. So how do we draw a histogram? Decide on the length of the base for each rectangle, so what width is all of these, and that dictates the length of your base. Make sure all rectangles have the same width. Draw each rectangle the correct height to represent the information it displays. So up here on the y-axis is the frequency, or the amount. Okay, so in this case it's the number of students. So we have to go from 0 to 24 on our y-axis. Okay, and then the heights of each of these rectangles represents the frequency. So that's why this one goes up to 8, because I have 8 people between 0 and 20. That's why this one goes up to 21, because I have 21 people between 20 and 40, and so on and so forth. Each rectangle must touch its neighbour, and then really important, label each axis, and just take the labels from here. You don't have to make them up. So the x-axis, the top row here, is always your x-axis, and the second row is always your y-axis. So your x-axis, just label it mark, and then your y-axis, label it number of students. Label each rectangle clearly, in other words, put in the 0 to 20, 20 to 40, 40 to 60, 60 to 80, 80 to 100, and give the histogram a title to describe the information. Now, strangely enough, this doesn't have a title, but it should. Okay, so the title I would give this one is what's in the question. So marks obtained by students, or students' marks. Okay, but a histogram should always have a title. So when you're correcting a Leaving Cert question, or any question at third level, any question on a histogram, this is what you're giving your marks for if you ask them to draw a histogram. So there will be a certain number of marks for each of these points 1 to 6. So don't miss out on any of them. Okay, so note, for the sake of drawing a histogram or using a histogram to work out frequencies, we say that the area of the rectangle represents the frequency. However, mathematically, we say that the area of each rectangle is proportional to the frequency of the corresponding class. That's not overly important. So read those 6 points there and draw your histogram. So now I'm going to do one for you. We'll come back to giving the histogram in a minute, but let's draw one first. Okay. Well, let me do this example here, because I have the table drawn in front of me, and it'll save us time. So the following frequency distribution gives the number of marks obtained by students in an exam. So 0 to 20, 20 to 40, 40 to 60, 60 to 80, 80 to 100, and the number of students. 1. Represent the data on a histogram. Name the modal class. Just writing down the questions. In which class interval does the median lie? On your histogram, indicate clearly where the median lies. Write down your value for your median. Okay, so let me share the page with you. Okay, so represent the data on a histogram. So like I said, the top row goes on your x-axis. So I have to go 0 to 24. So what I tend to do is start 24. Me go down in 4s maybe. 20, 16, 12, 8, 4, and 0. 4, 8, 12, 16, 20, 24. Okay. And then across the bottom. Of course, these need arrows because they go on forever. And 0 to 20. And I have to go up to 100. Okay. So let's have a think about how many boxes that would make sense. 4 would be a nice number. Let's see, do I have enough? So 20, 1, 2, 3, 4 boxes, 40, 1, 2, 3, 4 boxes, 60, 1, 2, 3, 4 boxes, 80, 1, 2, 3, 4 boxes, 100. So that looks good. So 0 to 20, 20 to 40, 40 to 60, 60 to 80, 80 to 100. Okay, so maybe it makes sense to do it in pencil at the start to make sure you get the widths right in case you need to rub out. There's no fixed way of doing it. You just have to look at your data and figure out how high and wide you could go. Make as much use of the page as you can. That's why I went over 4 boxes instead of 2, because visually it's just easier to see. Okay, so label my axis. So these are my marks, and up my side is the number of students. And then my graph is students' marks in the test. Okay. So 0 to 20 then was 8 people. So up I go at 20 and across at 8. Okay, 20 to 40 is 21, so a little bit above, that's 22, so halfway up here. Oops. Okay, 8 is also 40 to 60. 10 is 60 to 80, so that's halfway up here. And then 24 is 60 to 80. So all the way up to the top. And you can see each of these columns touch its neighbour. Okay, what I tend to do then, even though it's not required, is I just put the values in here. Again, just as a visual, because it's easy then to see the frequency for each column. Okay, so that's my data represented on a histogram. So the first question that was asked then was, what was the modal class? Okay, that's a more fancier way of saying what's the mode. It's just because they're not particular values, they are classes or intervals. That's why they call it a modal class. So which one is the most popular? Can you see that it is 24 is the highest number? So my modal class is 80 to 100. Okay, where does my median lie? Well, how many people have I in this test? I have 8 plus 21 plus 8 plus 10 plus 24. What I'm doing is I'm seeing what value is in the middle. That's why I'm doing this. Plus 10 plus 24. So it's 71. Half that is 35.5. So between the 35th and the 36th value is my median. Okay, so let's figure out my median then. Let's pick a different color. Okay, so 35. So if I add these two together, 8 and 21, I'm up here at the table. I have 21 and 8 is 29. And if I come in this side, I have 34. So I need roughly 35, 36. Okay, so can you see 34? It's just about in 40 to 60. So my median lies within 40 to 60. Okay, so that's the interval that my median lies in. Okay, indicate where it lies. Well, it's at the 35th/36th value, 35.5. So it is over this side of 40 to 60. Okay, because I need to be halfway, so I need another 7, 6.5 values out of these 8 to bring me up to 35 on this side, because I only have 29. So it's to the right hand side of this interval 40 to 60. Remember that the data is in numerical order. We have to have that for median. That's why I know that it's over on the right hand side, because this is where the bigger numbers will be. Okay, so if I was to draw that then on my chart, where am I? 40 to 60 is going to be somewhere over here. Okay, so I hope that's okay. I hope that makes sense. Okay, so now what happens when we're given the histogram and we have to do stuff with it? We have to calculate things from it. So sometimes we're given the histogram already drawn and we need to calculate the frequencies represented by the rectangles. We're usually given the area of one of the rectangles and its height. You can then work out the remaining frequencies for the information given. In histograms, it's useful to know that the frequency is equal to the area of the rectangle is the base by the height. Okay, let's have a look at this example. The distribution of the distances in kilometres that a group of people have to travel to work each day is shown in the histogram here. Given that the distribution has a mean mu equal to 8.4 kms and a standard deviation sigma equal to 4 kilometres, mark on the histogram mu minus sigma and mu plus sigma. Hence, estimate the number of people in the interval mu minus sigma to mu plus sigma. I don't get too put off about the Greek letters. It doesn't matter what they're called. They're just a title. Call them anything you want, okay? They're just letters representing numbers. Okay, so we have a histogram. It's telling us my mean is 8.4, so it's somewhere here. And again, if I could count the boxes, it would be easier to do that exactly. So in your exam, you'll see the boxes. It's just a little bit hard to see here. So 8.4 is somewhere here. So that's my mean. My standard deviation is then 4. So it's telling me to go from the interval mu minus sigma, so that's 8.4 minus 4, so it's 4.4, up to mu plus sigma, which is 8.4 plus 4, which is 12.4. So mark these two goalposts, if you want to call them that, on your graph, 4.4 up to 12.4. Okay, that's what they've done here in the diagram. Can you see that? Okay, and then it says estimate the number of people in the interval. So this is the hard part of the question. Okay, so you have to read the heights off the graph. So between 0 and 4, and sometimes it's nearly easier to draw out a table of your data. So between 0 and 4, I have 12 people, and I know that because it tells me here. Between 4 and 8, I have 28 people. I can read it off the y-axis. Between 8 and 12, I have 30 people here. And between 30 and, between 12 and 16, I have 24 people. Okay, so if I'm to estimate how many people are in the orange, okay, I know that everybody that's in the category 8 to 12 is part of that number of people. Okay, so those 30 people here that were between 8 and 12 are included as part of my calculation. Now, between 4 and 8, I don't have all of them. Okay, I just have some of them. So how much do I have? Well, I'm down here at 4.4. So I subtract that from 8 and I see that I'm 3.6 below it. So out of this full width of 4 to 8, I'm 3.6 of it. So it's 3.6 over 4 times 28, which is the frequency of that box. Okay, it's like the proportion of the 28 people that is coloured orange. And you do the same on this side, except you're just gone up to 12.4 here, so you're just 0.4 above it. So you're 0.4 of this width of 4, 12 to 16, times 24. So what proportion, which is very little, is just 0.4 out of the 4 times 24. And then you get your 3 values and you can add them together. So we're getting 57.6. You could say it's 57, you could say 58. In this one they also took 55, 56, 57, 58, 59. Why? Because in many cases, instead of being this precise, people estimate. Now it's much better to be precise, but you could estimate that out of these 28 people, you had about 24 of them. And then you could estimate out of these 24 people, you had about 2 or 3 of them. Add them together, and that's why people get these numbers here. Okay, because the question does say estimate, but you're much better doing it the exact way that's given here. Okay, let's try one of these examples. See, I have one drawn out here. I have this one. So the distribution of the ages of people at a meeting is shown in the histogram. Complete the corresponding frequency distribution table. That's part 1. Okay, so 0 to 10. How many people have we? Well, that's 20. And again, it would be much easier to see on paper. That looks like 10 there. It looks like halfway. This is half again. So that's 5. There looks like there's 5 people between 0 and 10. So I would put 5 in here. Then between 10 and 20, I am about halfway up. So there's 10 people between 10 and 20. They've told me 20 to 30 is 60. So that's fine. That's done for us. 30 to 40 in this case is up at 50. And then 40 to 50 here is up at, looks like 25. And then 50 to 60 is at 20. Okay, so let me just write those in here. So we said 5, we said 10, we said what? We said 50, we said 25, and we said 20. Okay, part 2, how many people were at the meeting? And 3, given that the distribution has mean mu equal to 43 and standard deviation sigma equal to 15, mark on the histogram mu minus sigma and mu plus sigma. Hence, estimate the number of people in the interval mu minus sigma to mu plus sigma. Okay, so let me switch to the pad and let's do that one. Okay, so very like the one we did before that I said was hard. So I've just, you can see here, I've just written in the values we read off the y-axis of that histogram. So how many people were at the meeting? Well, you just add them up. 5 plus 10 plus 60 plus 50 plus 25 plus 20 equals, just add them, 5 and 10 is 15, so 110 plus 45, 170 people. Okay, so those parts not too bad. Okay, it's the third part that gets tricky. And the first half of it is okay, as long as you're okay with the mean and the standard deviation and you understand the empirical rule and what that means. Because all they are doing is applying the empirical rule to a histogram. Okay, so given that the mean is 43, okay, so it's quite high. So that would be 45 on my chart, so 42 and a half. 43 would be roughly here. Okay, so that's my mean. Okay, my standard deviation then is 15. So mu minus sigma is 43 minus 15, and it's 28. Mu plus sigma, so these are like my goalposts, 43 plus 15 is 5 and 3 is 8, 58. Okay, so let's mark these ones in. So 58 is here somewhere. And 28 is up here almost at 30. Okay. So this is mu plus sigma, this is mu minus sigma. Okay, so it's all the area here that I need. How many people in this purple area? Okay, now you've got a good chunk of the marks just from marking in those two goalposts. Okay, but let's see, how would we estimate the number of people? Well, the first thing I would write down is between 30 and 40. So we have 20 to 30, we cross over a bit of that interval, and we cross over a bit of the 30 to 40 interval. We cross over a bit of the 40 to 50 interval, and we cross over a bit of the 50 to 60 interval. So I have the entire 30 to 40 interval. So I have those full 50 people. I have the entire 40 to 50 interval, so I have those full 25 people. Okay, now I don't have the full of the 20 to 30 interval. In fact, I've only got 28. Okay, so this is at 28. Sorry, this is at 28. So the width of this bit here from 28 to 30 is just 2. Okay, so you can do 2 over 10 if you wish. I'm just checking something out now for 1 second to see is there an easier way of doing it. Yeah. Okay, so I have 2 out of the 10 of that interval 20 to 30. How many people are in it? 60. Okay, I just have the area of it, because I'm going from 28 to 30, is just 2. So it's 2/10 of that area that I have of the 60 people that are in it. Okay, then up this end, I'm at 58. Okay, so can you see that in this one, that is an area of 8. So I have 8/10. I almost have a lot of that box. 8/10 of 20, and I got the 20 from here. Okay, 2/10 of 60 is 12, plus 50 plus 25 plus 8/10 of 20 would be 16. So if you add that up, you get what? 103 people. Okay, so you can see when the areas in the histogram are full, you have the full ones. It's easy to estimate it. It's a little bit harder to do the fractional ones. But that's how you do it. That's all there is to it. There's more examples in the book. Don't be afraid to try them. I'll just give you one there now. For example here, try question 2. That's not a sigma one, but try it anyway. Let me see if I can find a sigma one then. Question 2 and question 4 are two good ones. Okay, so that's your histograms. Obviously the hard ones are when they nearly give you the histogram rather than you having to draw it. Having to draw it is fine. Okay, so stem and leaf then. So stem and leaves are sometimes stem plots are sometimes referred to as stem and leaf diagrams. They can be useful ways of representing data. However, they are only useful for small amounts of data, e.g. a maximum of 30. They can be used to compare two samples together on a back-to-back stem and leaf. Okay, why would you use a stem and leaf instead of a histogram? Well, if you think of a histogram, you don't know the exact values in a histogram because they're grouped into intervals. In other words, these 6 students here that travel 2 to 4 kilometers to school, I don't know if they're 2 kilometers, I don't know if they're 3, I don't know if they're 3.5, and I don't know if they're 4. I just know they're somewhere between 2 and 4. The benefit of a stem and leaf diagram is it gives you the exact values. So if you care about the exact values, then you're better off with the stem and leaf diagram above a histogram. Okay. So how do we do a stem and leaf? Well, the number of minutes taken to complete an exercise was recorded for 24 students in a class. The results are as follows. Represent the data with a stem and leaf plot. Calculate the range, the median, the lower quartile range, the upper quartile range, the interquartile range. Well, you look at your values and you see your lowest and your smallest. So the smallest is 6 and the largest is 38. Okay, now I'm doing this to decide what my stem should be, and your stem is what's common to the numbers. So I have 30s, I have 20s, I have 10s, and I have units or noughts, okay? So I think that's what I'll do for my stems, and then your leaves are the values that falls in the noughts, the values that belongs to the group of 10s, the values that belong to 20s, and the values that belong to the 30s. Okay, really important that your stem and leaf must be in numerical order. It has to be ordered. However, it is often very useful to do an unordered one first, as it's drawn in this example. So all you're doing is really placing these into their categories. So 20, for example, became 2, 0. So that's your 20, 2 and 0. 9 has to be written as 0, 9. Okay, to make it work in the stem and leaf. 36, 3, 6. 24, 2, 4. Okay, see the 2 is common to the 20, to the 24. This is 25, 21, 26, and so on and so forth. An awful lot of people forget the key. The key is really important because it tells us how do we read our stem and leaf diagram. What does it mean? Okay, you pick any value at all. So for example 20, I will go 2/0 equals 20 minutes. Okay, the unit is always really handy. So the 2 examples they gave here was a key 0/9 equals 9 minutes, 1/7 equals 17 minutes. Okay, then they redid their stem and leaf to be ordered. Okay, you have to have it ordered. If a number occurs twice, like it does here with 21, see 21 and 21, we write it down twice. Okay, because our stem and leaves gives us every single value that occurred. So that's why I have 21, 21. So enter the leaves, crossing out the values as you record them. This is called an unordered stem and leaf. Then create a new stem and leaf so that the leaves are increasing order. Okay, and sometimes it's okay to go straight from here to the ordered. Okay, it depends. Okay, so let's then answer some of the questions. The range is max value minus min value. We did that one in the last video. So it's 38 minus 6, so it's 32. The median is the value in the middle. So we have how many? We have 24 students. So you have 2 choices. You can write all the values down here in a line in order, or you can count back 12. Okay, so 1, 2, 3, 4, 5, 6. You just have to be really careful on a stem and leaf that you're counting from the top end, you're counting backwards from the outside in. When you start at the start, you have to start with the smallest value, so you're counting from left to right. Okay, so some people are really good at doing that in a stem and leaf, some people go the wrong way. So if you're one of those that goes the wrong way, just write the values down here and find the middle value. Okay, I am one of those people who go the wrong way, so I have to write it down. So what you'll find is that because it's an even number, the value, there'll be two values in the middle, the 12th and the 13th, which in this case is 21 and 21. So here in the middle, and we get halfway between them to give us 21 minutes. Okay, the lower quartile then is 1/4, and the upper quartile is 3/4. So you find them, and your interquartile range then is Q3 minus Q1. Okay, so I'm going to do this as an example because I think it's nearly easier. Okay, so what one will we do? I'll come back to line plots now in a minute. So stem and leaf, I have taken down random numbers here. Question 4, so just have a read off question 4. Group of students use the random button on a calculator to select a number between 0 and 50. Here are the results. How many students are in the group? Represent the data on a stem and leaf diagram. Include a suitable key. Use the diagram to calculate X, Y, Z. Okay, so how many students? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 7 5s, 35 students. Okay, so represent the data on a stem and leaf. Okay, let me share. Okay, so stem and leaf plot. Let's have a look at my values. My smallest one is 1. My highest one is 49. Do I have a 50? I don't see one. Okay. The zeros, the 10s, the 20s, the 30s, the 40s. So the zeros, the 10s, the 20s, the 30s, the 40s. Okay, so let's start filling them in. So the first smallest one I see there is number 1. Didn't quite mean to cross them out like that. So number 1. Okay, the next smallest number I have is 2 and 2. So this is me trying to do an ordered one all in one go. I've already messed up because there's another 1. Number 4, number 5, and number 9. So one idea to do your stem leaf, if you're doing it all in one go, is to leave fairly large gaps between the numbers so you can fill in ones in between if you have to. Okay, so that's my single numbers. Now let's go for the ones. So have I any 10s? I do. 1, 2, 3. 1, 2, 3. Okay, and an 11. Any other 11? No, but I do have a 12. I have a 13 and a 13. I have a 17, another 17, and a 19. Okay, so 2's next. Any 20s? No. Any 21s? No, but I do have a 22, a 22, and a 22, and a 22. Twenty-three, 25, 26, 27, 27, 29. Okay, the 30s. 33, 32 there. 33, 33, 39. Okay, and the rest are 40s. There's a 40. There's a 43, 47, and a 49. So really important, you add them all up to make sure you have everybody. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. Okay, we're happy. So the key, pick any value is equal to 22, the number 22. Okay, so I don't have to put down in a unit. So that's my stem and leaf. How many students were in the group? 7 5s were 35. Okay. So I hope that makes sense. Okay, so then let's answer some of the questions. So the range then is max minus min, so it was 49 minus 1, so it was 48. The median value, okay. I'm just going to go on to the next page to do my median value. And let me write down all of the numbers. So this is what I mean by I have to write them all down in one go. So I have 1, 1, 2, 2, 4, 5, 9, 10, 10, 10, 11, 12, 13, 13, 17, 17, 19, 22, 22, 22, 22, 23, 25, 26, 27, 27, 29, 32, 33, 33, 39, 40, 43, 47, 49. Let me just count them again. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 35. Okay. So 17.5 values. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 1, 2, 3, 4, 5. I'm coming from the bottom now. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So you can see there's a single number in the middle, which is what I would expect because it was an odd number of numbers. So that's my median Q2. Okay. So the lower value then, 11, 12, 13, 14, 15, 16, 17. Okay, so my lower value, I'm just going to switch color so that you can see what I'm doing. So this is where I'm working out my Q1. So what I'm doing is I'm taking these values here now, which is the lower values, okay, and I'm finding the median of them. Okay, because isn't a half of a half a quarter? Okay, so let's do it again. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Let's come down another one. So there's a value in the middle. So that's my Q1. Okay, let's do it again. 1, 2, 3, 4, 5, 6, 7, 8. I'll go to 8 this time because I know it's 8. 1, 2, 3, 4, 5, 6, 7, 8. One value in the middle, and that's my Q3. Okay, so to answer the questions, the Q1 was equal to 10. Q2, which is your median, was equal to 22. My third quarter was equal to 29. So my interquartile range is Q3 minus Q1, which was 29 minus 10 to be 19. Okay, remember my range was max value minus min value, which was 49 minus 1 to be 48. So you can see your interquartile range is always much smaller than your range because it doesn't look at these outliers. It just looks like the middle of the data. Okay, let's go back to our questions. The range is done, the median is done, the lower, the upper and the interquartile range. State the mode. Is there a value that occurs most often? Well, yes, there is. There's 22. Okay. Sometimes a mode doesn't exist. Sometimes it's bimodal in that there's two modes. So in other words, if I didn't have 4 22s, if I only had 3, can you see 10 would be a mode and 22 would be a mode. That's it. Okay, so that's your stem and leaves. So not a bad old question, well worth the practice. Okay, so let's practice one of them. Let's pick one. I'm not really too bothered because there'll be a good few exam questions on this anyway. Question 7 is good. It's a back-to-back stem and leaf. Okay, so a back-to-back stem and leaf, if I could draw one of them for you. So a back-to-back stem and leaf is when you have a stem in the middle that's common to two events. Okay, so for example, over this side, let's go your mock results in maths. Let's go your leave insert results on the right. So you're comparing. Okay, so we would have 40s, 50. Just draw some lines first. 50s, 60s and 70s. Okay, so maybe they were the mock results. I shouldn't have the zeros in, it's just the stems. So 41, 43, 45, 46, I'm just making up values here, 52, 54, 56, 60, 62, 64, 75, 76, 79. Okay, so they were your mock results of those 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 students, 14 students. Okay, so then in your leave insert, your marks actually got much better. So I need to draw in 80s and I need to draw in 90s. Okay, because one person still got 40, they actually did worse. 2, 4, 6, 8, 9, 9, 80, 82, 84, 86, 91, 93, 95, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 students. Okay, so that's a back-to-back stem and leaf. You read left for the mock results, you read right for the leave insert results. Sorry, I didn't realise I wasn't sharing. Okay, so just to explain that again, what I did was I drew this stem in the middle, which was the 40s, the 50s, the 60s, the 70s, the 80s, the 90s, and then I plotted your mock results here on the left. Okay, so 41, 43, 45, 46, 52, 54, 56. Okay, and then when your leave inserts came out, you used the same stem and leaf diagram. One person did worse, they actually got 40 in their leave insert results, and then an awful lot of people did better. So 62, 64, 91, 93, 95. So we read that way then for the leave insert results. Why do we do a back-to-back stem and leaf? Well, so that we can compare data. Okay, so in a back-to-back stem and leaf, your stem must be common so that you can compare, and then your leaves will be different. Okay, so back-to-back comes up quite a bit. So that's why I think if you try question 7 for me before, it would be a good one to do. It looks like an exam question anyway. Okay, now the last one I'm going to do for you is a line plot. So a line plot just takes data and uses symbols, either X's or dots, to represent the frequency of a piece of data. So the one I'm going to do is 40 students, question 3, sat a general knowledge test. Each student was given a grade in the table below. Display the data on a line plot, write down the modal grade. Okay, so your line plot then . So I'm going to just show you a couple of things about the line plot first. This example that's here. So we have whatever we're plotting on the bottom, and we have really nothing on the top. So it's very, very visual. Okay, all they gave us was mode of transports and how many students. Okay, so for my one then, when I'm trying to plot these results that people got in a test, okay, I'm going to have one line at the bottom, and I'm going to say A's here, 2, 3, I'm going to try and keep it a little bit even, C, D, E. I don't know if that's everybody, but we'll try. Okay, so then what do? Well, for my first A, I give them an X or a dot, C, F, yeah, I do need F, D, B, B, D, E, B, B, A, D, C, C, A, B, C, E and F, A, B, 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 E, C, D, F, D, A, C, A, D. Obviously, it's better if these are on the same line so that visually you can see which is higher than the other. So keeping them within the boxes is a good idea. That's your line plot. Again, I would give it a title. I'm just going to write it, marks in a test. This is your grade down here. Okay, so display the data on a line plot, done. Write down the modal grade, well, which value occurred most often. Well, it's easy to see it was B. So not hard once you know what a line plot is. Yeah, make sure you know how to do them. Okay, so yeah, I think that's enough. We leave it at that, and the next video I'm going to do scatter diagrams and correlation and so on and so forth. Thank you.